Okay, I don't know if you guys realize this, but almost every single video I make starts with me going, okay. Um, let's talk about evaluating functions, right? Embedded here in the word evaluate is value, which means when we're done, we're going to be left with hopefully a number. If we plug in a number, we end up with a number. If we plug in a variable, we end up with what we call a variable expression like this, right? So just to review, this is the function f. That is the name of this function. Whatever shows up in the parentheses here shows up in the function here. The function f in this example does three things. It takes the input and multiplies it by 3. Well, two things, right? It takes the input, it multiplies it by 3, and then it subtracts that product from 4. That's what f does. That's what that machine does, right? So in other words, if we get very basic, if we plug in the number 2, we're plugging, since we're replacing this x with a 2 when we want to evaluate, we replace this x with a 2 and we evaluate, right? And then we're just following the order of operations, right? You all remember the order of operations, I'm sure. Okay. So we would do this multiplication first. We'd have 4 minus 6, and 4 minus 6 is negative 2, right? So the result of plugging in the number 2 as an input is an output of negative 2. All right, remember, x coordinate, this is a y coordinate when we look at the graph. Let's look at, what happens, and we can make this a little bit more complicated, okay? If we want to plug in a, this isn't more complicated, but if we want to plug in a, then my advice is always going to be whatever this is. I did it here, I kind of skipped past that. Let's go back. When I plug that number into the function, I should put parentheses around it, right? When I take a and I put it into this function, I should put parentheses around it. So this becomes, when I multiply, 3 times a is just 3a, so we get 4 minus 3a. So if I wanted to, I could express this as the input of a and the output of 4 minus 3a. This is what came out when I plugged that in. It looks really weird to write it like this. I couldn't necessarily graph it like this, but this is how we would express that. Okay, let's kick it up a notch. What if I plug in a binomial? So let's say I plug in, let's say x plus 3. Well, like we said before, if this is x, then this is x. If this is 2, then this is 2. If this is a, then this is a. So don't overcomplicate this. If this is x plus 3, then over here, I'm going to put x plus 3, and I'm going to put it in parentheses, okay? And this is why I say this is really important. Because if you just do this, all right, let's say you try to take this and tell me that it's 4 minus 3x plus 3. That's not right. Because all I've done, I've changed this by putting a plus 3 and I wrote the x here. Whatever goes in these parentheses goes over here in these parentheses. Okay? Now, follow the order of operations. The order of operations says parentheses first. Well, what can we do in these parentheses? Nothing. Are there any exponents? No. So then we multiply. Because this 3 is butted up against these parentheses, that means we're going to multiply it, right? What I do when I distribute this is I take this as a negative 3 and distribute into these parentheses, and then we end up with 4. Negative 3 times x is negative 3x, and negative 3 times positive 3 is negative 9. And then after this, we can add and subtract. We would combine the like terms of 4 and negative 9, and we'd have negative 5 minus 3x. Or, since both of these are negative, right, it could be negative 3x minus 5. It all depends on how you want to write that. So when I plugged x plus 3 into the function f, I got this. So again, it looks weird, but if I wanted to, I could say this was my input and this was my output. That's the ordered pair that represents the input and the output. You don't get asked for this a lot, but just trying to solidify that point. Okay, bottom line, whatever goes inside the parentheses here goes inside parentheses everywhere there was an x.